Once again, this first chapter is all about reviewing things you need to know to be able to get through the rest of it. The easy stuff, review, because it's going to get hard. Exponential functions, we will work a lot with exponential functions. The rules for exponential functions, it's a constant raised to the variable. It's exponential because the variable is in the exponent. The base has to be greater than 0. You cannot have a negative base raised to a power. It's not a function at that point. And it can't be 1. Because 1 to any power is 1. So it's boring. That's why I don't do 1 to the x power, because it's boring. It's just 1, no matter what. So I don't do that. The reason it's not negative is for it to be a function and for it to be continuous. Because calculus is designed to work with continuous functions. There's no gaps. There's no breaks. Now, we are smart people, so we will apply calculus theories and ideas to some discontinuous functions in ways that make it work. But the idea is if you have a negative base, let's say negative 2 to the x power, you've got to get from 2 squared, which is 4, to negative 2 squared, which is 4, to negative 2 cubed, which is 8, crossing 0, but negative 2 times itself will never be 0. So how can I get above the x-axis and below the x-axis without being 0 in between? You can't do it. It doesn't work. That's why you can't have a negative base. Okay. Domain and range is a big deal in stuff we're dealing with here. The domain, what is my domain on this? All real numbers. There's nothing you cannot have. So my domain is all reals. My range, greater than 0. Y is greater than 0. One of the aspects of all exponential functions, they are asymptotic. Some asymptotes go in one direction, some asymptotes are in another direction, some asymptotes are in both directions, some asymptotes in both directions are not the same. You'll have to get used to that. There was a question a few years ago they threw out. I was very angry they threw it out because it asked, what's the horizontal asymptote? There's one direction and a different one going the other direction. And I said the preponderance of people who got a 5 on the test answered it incorrectly with this particular incorrect answer, so I threw the question out. I'm like, no, it's a great question. It's a perfect question because it means you have to check both directions to see what the asymptote is. Exponentials always have asymptotes to them somewhere, or almost always. There are a few exceptions. It's very rare. Okay. So if we make minor changes, you want something that is decreasing left to right rather than increasing left to right. You make the exponent negative. Once again, the domain is still the same. All reals. My range is still the same in this one, greater than 0. Now, I said the base could not be negative. The base is not negative. If it has parentheses around it, then it's negative. Order of operations, what do you do first? Exponents or multiply? You do exponents, so you do the exponential before you apply the negative. This is one that Algebra 1 kids screw up, Algebra 2 kids screw up, and I've seen calculus kids screw it up. You have to remember the exponent before the negative. So I'm allowed to have a negative 2 to the x, just not negative 2 in parentheses to the x power. All the negative does is flip it over and put it underneath. Once again, it's all real numbers. And my range is everything less than 0. You've got to be able to identify domain and range. And you've got to be able to look at a function and get an idea what it looks like, have an idea from the equation, okay, what does it look like? Oh, an exponential. It's doing this. Is it going up left to right? Is it going down left to right, above or below the x-axis? You've got to be able to quickly glance at one and get a picture in your head of what the basics are. Not exact, but the basics of what the graph will look like. It will be extremely helpful. If you happen to look at the title of our textbook, it's Calculus, Graphical, Numerical, and Algebraic. Okay, the rule of 3, that's what that term came to be, the rule of 3. You study what it does graphically. What does the graph tell me about what's going on with the function? We don't need the equation if we have the graph to figure out a lot of stuff going on. We can do a lot of graph work in here. Okay. Numerically, what do the numbers tell us? You're going to work it out with actual numbers, get numeric answers. Algebraically, what's the algebraic situation going on? We're going to work with all three in here. It really is important to be able to jump, at least have an idea going back and forth with you. Rules of exponents. To quote Judge Reinhold's character in Fast Times at Ridgemont High, when he was speaking to Spicoli and his friends, learn it, know it, live it. Okay? Okay, yes, I am recording it. Everybody heard that one.
Sorry.
I've heard worse. I've heard worse. No, I cannot tell you how much being able to do some of these, and remember, all of these rules go in both directions. Taking it where you have an exponent of two things added, splitting it up, going from added exponents to two multiplied objects instead can be a tremendous help to you. There are times when applying these rules make all the difference in the world in being able to do what we need to do in here. It's one of those things that knowing these can save you simple steps. Knowing these can make a problem doable where it wasn't before. Okay? It is one of those ones. You've got to know these rules. Okay? Any questions so far? Okay. Solving for x. So what am I going to do in the top one? What's my first step?
Make the same base.
Make the same base. If you can't make the same base, then you go to logarithms. Those are another day. We're actually going to do logarithms later. And yes, logarithms are important to be able to do. Yeah, so you want to get the same base. 4 and 8. 8 is not a power 4, but they're both powers of 2. 4, 2 squared to the 2x minus 1 equals 2 cubed to the x. And when you raise a power to a power, what do you do to the exponents? You multiply them. So this is 2 to the 4x minus, 4x minus 2 equals 2 to the 3x. Bases are the same, powers are the same. 4x minus 2 equals 3x. Negative 2 equals, subtract 4 equals negative x. X equals 2. I think I did that right. Yeah, I did that right. Okay, notice I did not show subtracting 4x from both sides. I did not show dividing both sides by negative 1. At some point, you don't need to show every single step. Okay, you guys get to skip a lot of work. You get to skip a lot of steps. You have earned that right by being in here. However, when you're doing particularly your tests and quizzes, I need to see steps enough to know that I know what you're doing. You can't go straight from the problem to the answer. I need to see some intermediate steps in there. You'll see what you need to do as we go along. I can't give partial credit if I can't see the process. Because right or wrong, multiple choice, it's right or it's wrong. Other ones, if you got the wrong answer, I can give partial credit if I see a process that shows going in the right direction. Okay, so you'll kind of learn what kind of work you need to show and what you don't, and what works for you. Some kids have to show a lot of work because that's the way they need to do it. I'm fine with that. Some kids like to be lazy and not show a lot of work and skip to the end. You better be right if you do. Second problem, solve for b. This is another one where you're using the rules of exponents. So what I want to do is, this side's fine, the side on the left, e to the negative x squared. The other side, I want to combine them up as best I can. I'll do it in a couple of steps. First, that's e to the 2x times e to the negative 3. You've got to be able to move back and forth between numerator and denominator, changing signs of exponents. Okay. Doing work with stuff in the denominator, if you have 1 over something or a number over something else, you want to move it up to the numerator to do the work. It makes it a lot easier if you can. E to the negative x squared equals e to the 2x minus 3. Fairly straightforward. Negative x squared equals 2x minus 3. 0 equals x squared plus 2x minus 3. X equals, it is factorable, 3 and negative 1. So that would be my answers would be negative 3 and positive 1. Does that sound right? It's been 3 months since I've done any of that stuff too. So got to be able to do stuff like this. You got to be able to manipulate it without your calculator, but you should know how to do this on your calculator too, at least this part down here. Know how to do that on your calculator as well. Okay. Questions? Okay, E. Did you talk about E much in pre-calc last year? You did good. E is a beautiful number. I actually have a book, The Story of E. It's not a very good book. Not because books about numbers aren't necessarily interesting. That one isn't, because that one was just poorly written. Yeah, I have a collection of math books along those lines. E, The Story of a Number, really isn't very good. The Story of Zero is pretty good. I have one about 2 that's pretty good. Not all of them, but there's some ones. But E is an important number. We're going to use it a lot more. Do a lot of natural logarithms. We don't, almost all of our logarithms that we will do in this class are natural logs. Okay, we do natural logs in here, which is a lot of base E. Almost all of our exponentials will be E. Okay. These are just some basic examples. You've got to be comfortable working with these kinds of problems more than anything else. How long would it take to double your money if you invested $1,000? By the way, if you have a question that says, how long will it take to double your money? The initial investment is irrelevant, because it doesn't matter how much you put in. It will be the same amount of time to double it no matter what. Okay? It is actually irrelevant to have that. What you need is the rate and how much time. And we're looking for time in this point here. So, using those two ones, because double is what? Twice your initial investment. So if I look at the top one for doubling my money, that's 2P. Because P is my principal investment. It doesn't matter what my principal investment is. Okay? If I put $1,000 here and $2,000 here, I divide by 1,000. What do I get? I get 2. It's irrelevant. When you're doubling your money, it is irrelevant how much your initial investment is, whether it's $10 or $10 million. It'll take the same amount of time to double the money. So that's irrelevant. 1 plus my rate was 0.05 over N. N is compounded quarterly, so that's how many times a year? 4. It's 14. Daniel. Okay. To solve this problem, you need calculators. I'm not doing it by hand. Divide both sides by P, I get 2 equals .05. Turn it on first. 1.0125 to the 14th. First time I've used my calculator this year.
Yep.
When I get to here, I can't get the same base. What I use? Logarithms. Take the log of both sides. Natural log. Bring the power down out in front. Natural log of 2 equals 4t. Natural log of 1.0125. Divide by 4. Natural log of 1.0125. 4 natural log of 1.0125. So, what's your question?
Oh, no.
And I get 13.94 years. Does that work? I hope that works. Same thing using the other one. 2p equals p e to the r 0.05 t. Two equals e to the 0.05 t. Take the natural log. Natural log of 2 equals 0.05 t. That's what I love about using natural logs of e. It's just whatever the exponent is. Divide both sides by 0.05, so natural log 2.
This is the natural log over e then?
Yeah, because they're inverse functions. Goes away. So I get t equals 13.86 years. So you'll double your money about, what, a couple of weeks faster?
Yeah.
If it's compounded continuously versus compounded quarterly. This is why banks do not compound interest continuously, because having this formula to compound your money continuously is a really pain in the butt to work in your computers. But compounding it quarterly works really easy to do in the programs, and it doesn't really make that much difference, at least in the short term. It will when you get out to be about 50, 60 years down the road. It'll make a big difference. But not many people do investments that last 50, 60 years. Okay, 20 years is a long time for most investments. Okay. And frankly, I wouldn't put my money in a savings account now other than a safe place to stick it, other than a place safer to put it than your mattress. Because the interest rates they give you nowadays are horrid. 0.25%. When I was your age, you can get 3%, 4% on a savings account. You're not making a lot of money, but that's not bad. Now it's 0.25%. It's ridiculous. Okay. So I want you to do these two. See what you can do. Don't worry if you don't remember some of the stuff. Try to give you the formula for example number 1. Sample number 2, see if you remember how to do half-life. Okay. Do this because this is one of the things I wanted to see. Did you remember how to set it up? Once again, if you don't, it's not the end of the world. You're not going to be asked to do a lot of writing of equations. You will be solving them and simplifying them, but 9 times out of 10, you will be given the equation and how to set it up. So it's the new population 15,000 equals the initial population 10,000 times 1 plus the rate raised to t time. So let's see. And I get 25.54 years. Okay, does that make sense? Okay, the other one, there's the half-life equation. Just got to solve for x. First step, divide both sides by 5, and you get, here's exactly what I would do. 1/5 is 0.2, right? 0.2 equals 0.5 to the x over 20. Take the log of both sides. Natural log of 0.2 equals natural log equals x over 20, natural log of 0.5. Divide both sides by the natural log of 0.5 and multiply by 20. So natural log of 0.2 divided by the natural log of 0.5 times 20. And I get x 46 years, give or take. So why radioactive substances are so dangerous? They never quite completely go away. The length of the half-life determines how long they are dangerous for. Although there are some things that their half-life is measured in nanoseconds. That's just their existence. Some isotopes. Other ones, the half-life is 15,000 years. In which case, we're screwed. Any questions? Like I said, it's going back and learning the algebra.